So I hope you had a good time until now, like we had awesome speakers, right? So my name is Simona. Thank you for the introduction. I work as a cloud developer advocate in John Papa's team, which is fantastic. And basically before that, I used to work, I used to build network data platforms, data analytic platforms with Angular. And I've been working with Angular from maybe 2013, so I'm super passionate about it. The community of Angular is absolutely amazing. That's why I'm here.
Hey, my name is Artur, and I'm a full-stack developer for an IoT startup in London. And I've been using React since 2013, so yeah, pretty early in the timeline.
So we're here to talk about our experience with Angular and React, and how would you feel when moving from one framework to the other, and how do they maybe compare? And you might think of something like this, right? Woohoo! But we've decided that we're not going to talk about something like my KungFu is better than your KungFu.
Plus, clearly, I'm outnumbered, so.
You can find us on Twitter as Simona_Cotin or...
Hackaway.
Yeah.
The spelling's a bit different.
So let's start with Angular, because we're at Angular Camp, right? And the mission statement of Angular is one framework for both mobile and desktop. And Angular, the very first release of Angular has been in September 2014, and it's been released under the MIT license with over 400 contributors ever since. But we all know that actually this was not the first release of Angular, right? Angular has started way back in 2009 with Miško Hevery creating a framework called Get Angular, which was first tested in Google as a rewrite of the Google Feedback application. And basically, Google Feedback was an application that has been developed in 6 months. It had over 17,000 lines of code. And basically what Miško managed to do was to rewrite the entire application in only 3 weeks and reducing the number of codes to 1,000 lines of code. So that's pretty impressive, right? And that's exactly what Google thought as well. So they decided to continue sponsoring Angular. And as you know, AngularJS introduced concepts like dependency injection and two-way data binding, and brought MVC to the front end, right? But obviously, at some point, the Angular team, around 2013, they decided that maybe it's time to make some changes, because Angular has been like super popular. It's been tested in multiple projects, but then there were a few shortcomings. So they started into looking what would they add into Angular, and there were a few influences there. One of them was ES6, which brought classes and modules to Angular, and then obviously web components were very attractive because of their interoperability. React was a source of inspiration because of its one-way data binding, and even though two-way data binding was something that was like pioneered by or brought to front end by Angular, it was actually clear that it wasn't the best solution. RxJS brought to us better async. And TypeScript, well, who doesn't love TypeScript, right? It brought us error checking and awesome IDEs, which can help us do automatic refactoring and all the nice things. And finally, Ember CLI was also an inspiration for the Angular team, because basically we ended up forking the Ember CLI and bringing one of the best tools around in the Angular ecosystem, which is the Angular CLI. So then another focus for the Angular team was performance. And as many of you know, like performance is really hard to tackle, performance is really hard to improve, and that's because there's no single number, no single metric that you can measure in order to improve. So you have things like first-time render and change detection and route transition. All of them are important, and you have to focus on all of them. So the approach the Angular team took was to focus on improving two things, and one of them was the size, and the other one was speed. And one way to improve size is using the Angular router and lazy loading. And this basically allows you to download modules of your application later on, not necessarily at startup time. We also have, we have the ability to compile ahead of time, and this gives us faster rendering because the browser no longer needs to spend time on compiling our application. We also have fewer synchronous requests because you no longer need to download all, like the HTML and CSS is being inline, so you don't need to download all those files. We have a smaller Angular framework because we don't need to include the compiler anymore. When we're building, we can detect some template errors, like some bindings that are not okay. And we have better security because we can avoid some of the injection attacks because we're no longer evaluating JavaScript at runtime. So these are some benchmarks where you can see that the load time has been reduced by almost 60%. So as the size, which is pretty cool. And finally, we have tree shaking, which allows you to not import unused code in your final bundle. In order to take advantage of all these amazing features, you can use the Angular CLI to build your application by just running ngbuild ---- prod, which is basically prod is a meta flag that's enabling other flags like AOT, environment, and source map. And once you've done that, you can deploy your awesome application to Azure or any of the other cloud providers that you're interested in. And you do that by just copying the dist folder that has been generated by Angular. And off you go.
So the statement for React is that it's not a framework, it's a library, and it's a library for building applications with components. It's been created inside Facebook. Its creator, Jordan Walk, worked at Facebook, and he was friends with Pete Hunt. It got put into production in 2011, and it was being used for the Facebook newsfeed initially, but the true trial by fire of React came with the acquisition of Instagram. Instagram's website was struggling with the server-side rendering of images, and that's the role that React kind of scaled fairly well, as it would push some of the rendering capacity to the client side. And they released it open source in 2013, and it's been open source ever since. Some of the features in React are the fact that it promotes component-based architecture, predictable state management through third-party libraries such as Redux or MobX, and middlewares for handling asynchronous fetching of data. It has picked up ES6, and it does use its own implementation of strong types in JavaScript, which is called Flow. But the most interesting feature in React is the virtual DOM. And the virtual DOM is an abstraction of an abstraction, so basically inception much. So, okay, the virtual DOM is a way of representing the real DOM in a simpler way, and due to the fact that DOM changes are expensive and not efficient at all. It allows React to batch these changes and push them to the real DOM. The most important part for the real DOM is the reconciliation algorithm. We are seeing the second iteration. The first one was, in hindsight, named the stack algorithm because it used recursive calls and it parsed the virtual DOM to check for changes. But nowadays, it seems like a highly inefficient way to do things because it will get blocked while it's looking for changes. And here you see an example of a really rendering intensive component on the old version of the stack algorithm. And the new one is much smoother, as you can see. It's highly optimized. And the thing that's been optimized is that the main thread will periodically return return execution to the main process, and it will allow it to pass in some smaller chunks of work that need to be done.
Okay, so we've seen a small introduction of Angular and a short introduction of React. But then what do we need to do to get started with each of the frameworks? And obviously, starting with Angular just means that you need to install your Angular CLI. Well, you can build the project yourself, but then it wouldn't be as fast because the Angular CLI gives you things like automated, configurations for your build, configuration for testing with Karma and Jasmine. And it also gives you a base, the root module and the base component, which enables you to start writing code according to best practices. And you just need to install from npm your Angular CLI and then just run ng dream app. What about React?
So in React, it's pretty much the same story. We have React create React app. There's a typo there. And it will give you the CSS, some boilerplate for the tests, and the components, and it will also give you a file for a service worker, which is for progressive web apps.
Cool. So you mentioned the component there. So having a look at Angular component, basically Angular component has two parts to it. The first one is the component metadata, and you declare it by adding the add component decorator, as I guess all of you know already. And you have the selector there, which is the tag that you're going to use in your template for your component. And then you can add your template inline, or you can specify a template URL. And you can also add style for your component. In the class of the component, you are specifying the behavior of the component and you can also add state to it or event handlers, right?
In React, and I'm going to say this again, it's pretty much the same story. You have the templating, which in this case is inside the component itself. It's not outside, so you will use JSX to render it, but it's part of it, your component. It's not external. And then you implement functionality through the methods of the class. You can also include CSS through Webpack CSS loaders, and you can just import them as normal modules.
So this is quite fun, right? Everything looks quite similar, it seems quite simple, but then I got the opportunity this year to work on a more complex React project, and I started getting into the more complex stuff, right? So the #1 developer question, most asked question is, what is the difference between state and props? Like you have, as you can see in the previous slide, you have both state and props, and like they look the same. Why do they exist?
So when you're talking about state and props, state is internal to a component, and it's mutated inside that specific component. and is generally in React a bad idea. The ideal way to pass in data into your components is through props, and that happens from the parent to the child.
So basically this goes into a more general conversation, which says that you can have smart components and you can have dumb components. And the smart components will be the ones that will be smart enough to handle your state, and the dumb components will just be oblivious to state and make sure that they display whatever they're meant to display. And this means that we can take the previous component and we can refactor it into two different components. The first one being comment list container, which basically handles the state, and it passes it to the child component, which now receives it as props, and it renders the final HTML. So there's a clear separation there, and normally it's nice to have that. Okay, so we've talked about props and state, but then this reminds me, how do I manage state?
So the way to manage state in React, the recommended way at least, is Redux or MobX. Redux is an implementation of Flux, and it has store implementation, which in React applications, the store is the single source of truth. So all the state of your application will be in one place, and it allows you to do really cool stuff such as time travel debugging, which is pushing your application to a specific point in time. For example, for finding a bug that only manifests in some particular state. But you have trackability of this through Redux.
Time traveling, that sounds interesting, right? And this is actually the code for how you would use Redux in React. So basically you create your store, which is your single source of truth in your application, and you pass it in a set of reducers, and then in your component you are dispatching some kind of actions like increment or decrement, and then your reducer will then match those actions to a new state and return that. Okay, and then as an Angular user, I'm actually kind of spoiled, and I know that I can use HTTP, it's out there, or maybe observables. Everything's within the Angular parameter, so I don't have to go outside and look for how do I request data, but then in React.
Yeah, React, reiterating, it's not a framework, it's a library, but I guess you guys know this by now. So most of the extra features that need to be added to any functional real-world application are third-party, and they've been tested and put into practice by the open source community. So basically, it's provided by GitHub with love in most cases. For example, for fetching, you would use Axios or just the normal standard fetch.
So you have so many options. What does one do? What does the other do?
The fetch is just the standard way of doing things in the browser, or you could use Axios and you have some extra configuration and it returns a promise and you resolve that and put the data into the store.
That's great. Sounds good. So then the next important thing when looking at web frameworks is that are component-based is how do my components communicate? And obviously you have different layers of communication between components, and you can either talk from your parent to the child component. Otherwise you can talk from your child component to your parent, or you might want to communicate between components that are not necessarily related. And the first case is actually quite easy. You just need to pass in props from your parent. So in our case, from my container, I'm just passing the checked state into the toggle button, and that's pretty much everything that I need to do to pass data in. What about child to parent?
Well, child to parent, to be fair, it can be done. But as you look at the code, you'll see that it's a little bit more cumbersome, and that's because it's not the recommended way to do it. Most of the stuff that you're allowed to do, you're going to be able to do in very few lines of code. In this case, in order to communicate with the parent, you pass a callback from the parent to the child, and the child will pass as a parameter its state to the parent, and then the state of the parent will be able to change accordingly to the state of the child.
So it's almost like real life. Kids are not meant to speak to their parents, right?
Not really, no, not with React.
There's no protocol there. And then the more complex case where you have to pass data between components, I guess that there you have some patterns, or how does it work?
So Redux, going back to the previous slide, the child component should communicate with the parent through Redux, ideally, because it's very easy. So the way the communication flow works in React is a component dispatches an action, it is matched against a reducer, the reducer changes the store, and then the store returns the change state to the component, and the component will re-render if it needs to.
Okay, so basically you have event emitter and observables, which sounds kind of similar to what we have in Angular as well. So after seeing all these things happening in React, when you're coming back to Angular, you realize that NGRX exists, and that's basically a statement that Angular developers loved Redux. And it's a statement for Redux as well, how well it handles like state management. And the way you would implement Redux in your Angular application is by basically creating a store, and then you're still dispatching actions. Yeah. And then your reducer will catch those actions, and that's pretty much everything. And another thing that I found very useful, as I mentioned before, is the fact that you have this separation between stateful and stateless, and this allows you to nicely architect your application and make most of your components more reusable and your application as a whole more maintainable. So that's something that I would bring back to Angular from React. So we've seen how you write code and what kind of libraries you would use. What about tooling? How does the day of an Angular and React developer look like? Well, in terms of Angular, you would just go sip your coffee, open Visual Studio Code, right? Make sure that you have John Papa's snippets installed, and then, well, they're good, right? And then you would maybe open your Angular CLI to generate a new component or a new service. And then if you want to be a responsible developer, you would write some tests, right? And you can use Protractor for that. And if you want to have a look at your application state, you would use Angular Augury for that, which is a tool implemented by Wrangle.io. And then, obviously, language services will help you with things like autocomplete and error checking. And yeah, we have everything, basically. We're happy developers. Your turn.
So, you just need the linter. Basically, the one that is most widely used and I found in most projects is the Airbnb ESLint config. It's available as a NPM package. So basically, you just NPM install, and you have what you need to detect style no-nos and things like that. For the editor, some people use Atom, some people use Sublime, Vim, Emacs, and the list is endless, pretty much. For debugging, it has some really cool tools. I was mentioning earlier time travel debugging. But yeah, let's start with what's first. So the browser console, any JavaScript application benefits from it. React Developer Tools, which will allow you to inspect the DOM, and you'll see your components in the DOM with the names the components have. And then for Redux state, you will have Redux DevTools, which allows you to do time travel debugging, which is quite good, really awesome. I recommend you try it out if you get the chance. The coding and the architecture guides. These are highly different, diverse, and they're all available open source. So you're going to learn how to write React code by writing React code, unfortunately, but there's people out there to help you, and you can, get started fairly quick.
So reach out to the community, right?
Yeah.
Okay, so as with all nice things, we also have challenges, right? So we were wondering what's the most asked question, uncomfortable question that an Angular developer can get, and I guess that everyone knows the answer to this. Basically, there's no migration path between Angular 1 and Angular 2, and it's something that as an Angular 1 developer, once you've built a really large and complex application, and then you find yourself here and you're asking, well, I'm working with this obsolete code, right? It's not necessarily true. The project is still updated, and then obviously there's tools there to help you make the transition easier, and you can use things like, first of all, write your code according to the Angular style guide. Go read the style guide. It will help you write things like components, and it will guide you through everything. Start adopting TypeScript. I've used TypeScript since 2014, maybe, with Angular 1, and it was actually a super good experience. I totally recommend it, add it to your project. Use things like upgrade module to actually start the upgrade process, and Victor Sufkin has a really cool article about migrating your application in 5 steps. And also there's an Angular cookbook on their website, which includes an upgrade cheat sheet, so you could use that as well if need be.
So yeah, this is I promise this is the last time I say it. React is a library, not a framework, so there's no fight here. You see the slide? So the things you'll find most difficult when coming to React is state management, and the thing you must be aware of is that you have to come up with a good solution up front for state transitions in your app. So the state management can be daunting, and on top of that, there's also asynchronous state management, which means you have to wait for the data to come back for the server and then change your state. This can be achieved through middlewares or sagas. So yeah, just to conclude, there is no unified way of doing things. So you need to be aware of that, but the community is there to help you. There's a bunch of ways you can do things. Just ask.
And I'm going to be the devil's advocate here. I read this nice article. I don't remember the whole thing, but the thing that stayed with me was that React is built on Linux mantra, which means that is much more focused on having small composable libraries that allow the community to build whatever they need and interchange when something better comes along. So I thought that was really nice, because we all love Linux, right, as well. And if you think we have React, we have Angular.
If you like React or you like Angular, if you don't like either, like both, there's always Vue. Just saying, it's a new up-and-coming framework, so you could try that out as well. It's very similar to both. But
kid aside, actually, if you have this, if you think of this as a battle, which is not, definitely, if there was a winner, it's actually the community, right? Because as you could see, most of the frameworks that are leaders now, like Angular, React, and Ember, and Vue, they all converge towards the same features, and they all challenge each other to create a better web for us eventually. And I think that's absolutely fantastic. And yeah.
I think we all win in this particular scenario. So, yeah, thumbs up.
We're the winners. So thank you so much.
Thank you.
Yeah. If you have any questions about Angular or React or Azure, reach out, Twitter, or you can find us today.
Yep. Cool. Thank you.
Thank you.